Now another type of application for this problem I am discussing here. Find the locus. As a word locus comes in the dictionary. Locus is the path of a point. Locus is the path described by a point in a plane or in space. A circle is also a locus. A sphere is also a locus. Right bisector of any line segment is also a locus. Angle bisector of any angle is a locus under some geometrical conditions. So the problem is find the locus of a point which is equidistant from two points whose coordinates are given 0, 2, 3 and 2, minus 2, 1. Suppose there is a point P whose coordinates are x, y, z. These 2 points A and B are located like this 0, 2, 3 and B 2, minus 2, 1. P is any point x, y, z. A and B are the two fixed points. P is a point which remains always equidistant from A and B. We need to find the path, equation of that path, equation of that line on which P remains, moves but maintaining the equal distance from A and B always. To find it, we can say we have PA is equals to PB, or we can say PA square is equals to PB square. We can apply the formula of the distance between PA and PB. So answer of PA square will be somehow like this: x minus 0 square plus y minus 2 square plus z minus 3 square is equals to PB, means you can see concentrate x minus 2 square, y minus of minus 2, that is plus 1 square, and z minus 1 whole square. This is the relation PA square is equals to PB square. If we solve it, we will get x minus 2y minus z plus 1 is equals to 0 is the locus or equation of the path, same meaning, of that point which is movable at equal distance from given point A and B. So locus is nothing but a condition as per requirement of the question.